Okay, good morning everyone. Today I'm going to talk to you about the some of these equations of straight lines that we learned back last year during math class. Now, in grade 8, my then mathematics teacher, Miss S.P. Joan, came in and gave us a supplementary worksheet in these equations of straight lines. Since it was out of syllabus, I didn't really care, and I really didn't memorize them either. And this year, however, Dr. Lowe came in and really explained how these equations worked, and then since then they've stuck firmly in my mind. And I'm going to demonstrate that to you by really reciting these equations. Okay. So the first one is the general form, aka the useless form, which is ax plus by plus c equals 0. The second form is the slope-intercept form, or the useful form, y equals mx plus c. The third form is the point-slope form, which is y take y1 over x take x1 equals m. The fourth one is the 2-point form, which is y take y1 over x take x1 equals y2 take y1 over x2 take x1. And finally, the intercept form, which is x over a plus y over b equals 1. Now, the focus of my presentation is less on these equations themselves, but on how I acquired them. Now, the first way of knowing that I use is intuition. It's not really a term you commonly associate with mathematics, perhaps, but to me it's very, very important. Now, what is intuition anyways? So according to this D. Hain person, it is fast, automatic, and inaccessible to introspection. So how might intuition come into play with these equations of straight lines? I want you to look at number 3, number 4. The intuition behind these two equations is fairly simple. Both sides of the equation is just the slope. Okay, the left-hand side is delta y over delta x. The right-hand side is delta y over delta x. There's no hardcore memorization needed if you simply understand the intuition behind these equations, how these equations actually come about, then they are already firmly registered in your mind. Some people might be saying, okay, how can we be sure that, how is intuition so useful in a subject as rigorous as mathematics? Now, we have a very authoritative figure here, Gödel, a person who went into an asylum because he got obsessed over a mathematical problem. Now he says, I don't see any reason why we should have less confidence in mathematical intuition than in sense perception. Now indeed, intuition is just gets you started on a problem. When intuition really tells you how to start, what's the first step you should take in solving a problem, and a good start is halfway completed. So intuition is really, really important. And the second way of knowing will be reason. So some of these equations, especially number 5, you can't really find an intuition or an intuitive approach towards it, and you would really like to derive this formula from some other equations, okay? So definitely reason very important in mathematics as well, and logical deduction. And the third term is something, again, you probably won't associate with mathematics very often, which is imagination. Now, if you don't believe me that imagination is very important, I'm going to now ask you to lift your head and look at the ceiling. What do you see? Okay, you should see some lights, air conditioner maybe. When René Descartes, a mathematician philosopher, woke up one morning, he looked at the ceiling and he saw, the ceiling fan, whatever, and he said, oh, wouldn't it be great if I could represent the positions of these objects using some numbers? And he invented the Cartesian plane, which is the rectangular coordinate plane we see all the time in mathematics. And the invention of this plane couldn't have come about if Descartes hadn't used his imagination, because how else would you be able to look at the ceiling and see a coordinate plane? Like, definitely imagination, very important here. And there's an article I really liked when I found online from the Harvard magazine. It says, the lunatic, the lover, and the poet, said Shakespeare, are of imagination or compact. You forgot the mathematician, whose daily concerns are shapes in 27 dimensions, series that converge after more terms than there are particles in the universe, numbers larger than infinity, and others infinitesimally small, as well as surreal and hyperreal. People who intermediate between lunatics and the world used to be called alienists. The go-betweens of mathematicians are called teachers. Many a student may rightly have wondered if the terms shouldn't be reversed. Those wonderful artworks of the imagination the mathematicians produce rarely make it to the classroom, where mind-numbing drill in what seems a dead language tends to rule instead. So how can we bring imagination into the classroom with these 5 equations? The simple imagination that you really need is when you look at these equations, you want to be able to visualize it immediately. So y equals 2x plus 3 looks like that. X over 2 plus y over 3 equals 1 looks like that. And when paired with intuition, these two together are really going to give you a strong start into how you're really going to solve a problem. Okay, so this is why I think imagination and intuition are so important. Final way of knowing is memory, which really I think is the least important. And honestly, I use the 3 so intuition, reason, and imagination. These 3 combine to give me the memory, so there's no real hardcore memorization needed. Now, on to some real life applications of intuition and imagination. I'm going to ask someone, hello Thomas. So here we have a basket full of apples. The apples themselves without the basket weigh 2,000 grams, and we know that each apple weighs 100 grams. So how many apples do we have in this basket? Right, that's going to be 20 apples. That's very straightforward. I'm going to ask you a very similar question. If we have 480.0 grams of oxygen, and we know that the molar mass is 16.00, how many moles of oxygen do we have? Right, 30 moles. Very simple. So what we've done here is we've taken this equation for mass and molar mass, and we've given it a slap on the face. We don't need this equation because we can imagine moles stoichiometry in terms of apples and baskets of apples, and then use intuition because that's what you would use if you're buying apples at a supermarket. Okay, so there's no real memorization needed. It's just intuition pairs with imagination, and we have successfully applied this to a problem in chemistry. So the definite takeaway from this presentation is that if there is an intuitive approach to a question, always take the intuitive approach because it's going to take you further than approach solely based on memory. And it's going to be far easier as well. So I'm going to end with a question. So if I say that intuition, mathematical intuition, is so important, is it possible for us to develop it to up our game? And if yes, how can that be done? Okay, this is the end of my presentation. Thank you for listening.